All right, now let's look at enzymes. Enzymes are a very special subgroup of proteins. These are called biological catalysts. A catalyst is anything that'll speed up chemical reactions, but when we say biological catalysts, we're talking about catalysts that are necessary for life. Now, the way they do this is they lower the amount of energy required to start a reaction. So let's say that we have some initial reactants here that are going to join together to make a product. But for this reaction to proceed, there has to be some input of energy. And so this input of energy is very high naturally. However, an enzyme can actually lower the activation energy so that it requires much less input of energy to get the reaction going. And in that way, it'll go faster. So enzymes speed up our chemical reactions. Now, there are several properties of enzymes that you need to know. The first is that they are specific, okay? And the thing that is used to relay how specific they are is the lock and key model. The idea that if you have a lock, only one type of key will fit in there. And no, there's no such thing as a master key in this case. So here's our enzyme. Notice it has this very particular shape, and let's say it wants to find its substrate. Now, these are some example substrates, and the substrate just means the thing that the enzyme will work on. Now, it can break it down, or it can change it, or build something, put it together. In this case, let's say the enzyme is breaking something down. The enzyme is not going to just break down any of these. It has to fit into this active site is what it's called. So this active site has a very particular shape. It's not going to allow just anything in there. So this one right here is going to be the substrate for this particular enzyme. Some examples of enzymes are peptidase. So you can gather some information from the name. Peptides, remember those are proteins that we looked at in the last video. So a peptidase enzyme is going to break down peptides. Lipase will break down lipids. Not all enzymes are easy to figure out what they will break down. Amylase will also break down a macromolecule, and this particular one breaks down glucose. I want you to notice a trend though. We have ACE, ACE, ACE. Anytime you see ACE, you should know it's an enzyme. And make sure that you are not confusing it with OS. Anytime you see OS, it is a sugar for the most part. The second property is that enzymes are reusable. They're not used up in a reaction. Think of that lock. That lock is not going to change forever in the reaction. Now, we'll talk in class about how this lock and key model or analogy doesn't work in every sense of the analogy. But I just want you to keep in mind that once a peptidase enzyme breaks down a peptide, it can then go on to break down another peptide. Actually, you can think of it like scissors. Scissors would be your enzymes, and a piece of paper would be your substrate. Once the paper is cut, it is changed, but the enzyme, the scissors, do not change after the reaction. They can go and they can then cut more paper. All right, the next property of enzymes is that they are affected by temperature. Now, the higher temperatures are good because it speeds up molecules, and the faster an enzyme can get in touch with its substrate, the faster the reaction will occur. However, if the temperature is too high, then the enzyme will denature. And proteins denature in general if they get too hot. But what this means is they lose their shape. And if an enzyme loses its shape, it cannot work. Think of scissors. If they lose their shape, they cannot work. If the temperature is too low, the reaction actually slows significantly, almost to a halt. So if it's too cold, the reaction just won't proceed. The next property of enzymes is that they are affected by pH. So pH is a measure of how acidic the environment is, and every enzyme has an optimal pH. For example, your stomach acid, there's very acidic conditions, but those proteins and those enzymes in particular in the stomach that are used to break down your food, they work well in those acidic conditions, which is good. Now, if there are some other proteins in there, they're probably, there's some enzymes in there, they're probably not going to work very well if they normally work in neutral conditions. And most of your enzymes work in neutral conditions. The last one is enzymes are affected by their concentration, or by not just their concentration, but concentrations of specific things in general. And the reason for this is an enzyme's speed of reaction depends on how easily it can find the substrate. So how easily can the enzyme find its substrate? If you have a very low concentration of enzyme, well then, okay, yeah, the enzyme can find the substrate, but you're still going to have a slower rate of reaction because you don't have that many workers, and the enzymes are the workers. Low concentration of substrate, I mean, if you don't have anything to work on, it's going to be very difficult for that rate of enzymatic reaction to go up. And high concentration of product. This is the interesting one. This is, if you think about the fact that when an enzyme works, it is creating some kind of product, and that product will still be around in the solution or wherever it's working. That product will start to get in the way of it finding its substrate. So when you have a very high concentration of product, again, that's going to start to slow down the rate of enzymatic reaction. Okay. So those are 5 properties of enzymes. You need to be very comfortable with those and be able to explain them and list them and discuss them in class. All right, that's all.